the goal of this presentation was to provide like I would say 40-minute overview on the OSCAR framework so that everyone interested can have a look into this, and then we will have some time for questions. So here you have in this link the URL that we will be redirected to this presentation. So anytime you will see that they have included some videos so that you can follow along. So my name is Germán Moltó. I'm professor at Universitat Politécnica de Valencia, and in this presentation we will talk about deploying our AI-based services for inference using the OSCAR serverless platform. So here we have the life cycle of an AI service, and here we are at step 3 when we want to deploy our AI-based service for inference after having built and developed the AI service and after having trained the model, in this case in the AI4EOS platform, which is powered by the AI4OS infrastructure. So let me just take a look at this approach. Here, what we want to tackle is to perform AI inference, what we call in the computing continuum, which is basically in the underlying layers at the edge of the network, very close to where data is being produced, and there are some devices that capture this data. Then we also have the on-premises layer in which we can have resources within our institution. And in the upper layer, we have a cloud. So we are talking here about EGI Federated Cloud or public cloud providers such as Amazon Web Services or Microsoft Azure. And across all these layers of the computing continuum, we want to do AI inference. And we are facing some challenges regarding to the elasticity of the platform. We want to adjust the computing resources to the demand that changes at any given time, depending on users. We want to support multiple cloud platforms. We want to deploy our AI inference platform across multiple cloud providers and even computing architectures. We have ARM-based devices. We have AMD64. We have several computing architectures. And we want support for AI inference pipelines. So the challenges that we are facing here is that once the user has trained the model, and the model is typically packaged in a Docker container, typically, and we want to run this model as an inference server on top of a distributed computing infrastructure. And for that, we need a middleware. And the challenges that we face is that the users want to deploy these models for scalable inference. That means what I was referring earlier about this automated elasticity, including more resources when it is required. And here we are proposing to use serverless computing, which is a computational paradigm that abstracts the dynamic allocation of resources using this approach of event-driven computing. So when a user wants to trigger an inference of a pre-trained AI model, it typically uploads a file to a certain object storage system. And then this triggers a system that executes this Docker container on a container orchestration platform that runs on a virtualized infrastructure on top of a physical infrastructure. But the user can also trigger a request or an inference request into this computing engine. So here we have like two approaches: uploading files to an object storage system or triggering an inference request into this serverless engine. And in this scenario is where our OSCAR platform fits. This is an open source platform that supports the serverless computing model. And by serverless, I mean automated elasticity and this event-driven. So when the user wants to upload a file to an object store or to trigger an inference request. And this executes Docker-based applications on a container orchestration platform such as Kubernetes. We are able to deploy these OSCAR clusters because these are composed of several virtualized nodes on multiple cloud infrastructures. And for this, we are using the infrastructure manager, as we will see. We are supporting several computer architectures, such as these low-power ARM-based devices, which are very efficient. For example, Raspberry Pis or NVIDIA Jetson, NVIDIA Nano. And this allows to do AI inference at the edge of the network. And this framework that I'm presenting today is also integrated with another open source framework that we developed in our research group, which is called SCAR, which allows to run Docker containers on AWS Lambda with automated delegation on AWS Batch for GPU-based computing. And this allows us to create data processing workflows along the computing continuum. But we will see a bit more on this later in the presentation. So just some words on the architecture. This doesn't need to be known for the use cases, but just to know what's going under the hood. Basically, here what we have is min.io, which provides it's an object storage system, so users can upload files into this object storage system, which, by the way, provides the same API as Amazon S3, which is the object storage system provided by AWS, which is the leading public cloud provider. And once these files are uploaded for inference, and this triggers a job that is executed in a Kubernetes platform. And these jobs are being executed in this elastic Kubernetes cluster, which can optionally enlarge and shrink in terms of the number of nodes. So you can have a different number of nodes depending on the concurrent workload. And this Oscar cluster is dynamically deployed using the infrastructure manager. We are supporting several storage backends, popular scientific storage backends such as Dcache and OneData, which is the technology under the EGI Data Hub. We are supporting Amazon S3 and min.io and other web app providers as well. So regarding the components, I already provided a brief overview. We're using the infrastructure manager to deploy the Oscar clusters on multi-clouds. I will talk a bit later. Then we are using Knative to run functions on top of this Kubernetes cluster. We are running jobs inside this Kubernetes, and we are using this Oscar Manager component that interacts with all the aforementioned components. This is an elasticity system so that the cluster can grow and shrink. But let's focus more on the use cases that we want to solve. So the easiest approach is that the user that wants to trigger inference on, let's say, for example, an image out of a pre-trained model, it just uploads files to a min.io bucket, and you upload n files. It triggers the execution of n jobs in a scalable Kubernetes cluster, and the output result is stored in min.io. So it's as simple as this. And under the hood, it's automated elasticity, dynamic management, and easy interfaces for the user. This is what we call the asynchronous invocations. But we also offer these synchronous invocations in which you have an AI model. It's running as a set of containers that are kept up and running for let's say, low latency. And the user can trigger HTTP calls to these warm containers that are kept up and running in order to trigger fast inference. And here the benefits are that the number of containers can change at runtime, but also the number of nodes of the underlying cluster can also change. So we have this two-level elasticity so that the resources are configured to the dynamicities of the users that are using the Oscar cluster. So we are providing here several interfaces. We provide a REST API. We're providing a web-based user interface. We provide an Oscar CLI, which is more convenient for programmatic access. And we provide some bindings for certain programming languages, and Python is one of the popular ones. So we provide a Python Oscar a client to interact with the Oscar cluster. Now, if you want to try yourself this technology, you can deploy a local Oscar cluster. So you see that this documentation, these slides provide links to the documentation, so you can follow along, and you can easily install Oscar by using this command, and it uses Kubernetes in Docker. So if you have Docker, you can deploy this cluster and do some testing locally. Of course, this doesn't have, let's say, HTTPS certificates, but for easier testing, it's a nice approach. This is one approach to deploy your Oscar cluster locally for testing. The other approach is to go to the infrastructure manager dashboard right now and deploy an Oscar cluster on whichever cloud platform that you have access to. And let me just open an easy video in order to tackle this. And you will see that here in the infrastructure manager dashboard, which is available without any registration. So you connect and you log in with your home IDP, and you select the ability to to deploy on a specific cloud. Here we are deploying an Oscar cluster on an EGI federated cloud under, in this case, the EOS Synergy virtual organization. But if you are belonging to the Imagine virtual organization, you can deploy an Oscar cluster there easily with this dashboard. And you will see that you need to configure the name of the cluster. You need to configure the name of the size of the Oscar cluster in terms of working nodes, the tokens required to access Kubernetes, the tokens required to access Oscar, and then the cloud on which you want to deploy this Oscar cluster. Then we will select or see the free resources. We select the virtual machine image. And this is an automated approach. So you can easily, with some clicks, deploy an Oscar cluster on whichever cloud infrastructure that you have access to. Public cloud providers, OpenStack, OpenNebula, EGI Federated Cloud, or whatever. So it's quite convenient. It takes like 15 minutes or so, even less. And once it's configured, then you can see in these output sections the links to connect to the Oscar cluster. And you will see that you are even provided HTTPS, TLS certificates integrated in this endpoint, so the communication with this cluster is secure. And there you go. It's very easy to deploy an Oscar cluster. Now, let me just silence this because it has some audio in the background. Another approach is to try yourself on an already deployed Oscar cluster. And in the context of the AI for EOS can Imagine projects, we're providing a pre-deployed Oscar cluster mainly available for testing. So you can either go to this URL or this other URL. These are URLs which provide a customized entry point with the logo of the project. And you can use EGI check-in. You need to be a part of the EGI check-in, the production version, not the demo version or the devel version, to authenticate and access the cluster. You need to be part of the A4EOS virtual organization or part of the Imagine virtual organization. And currently at the moment, this Oscar cluster is shared among both projects. It's provided as a sandbox for use cases testing. I mean, the capabilities are not very high. We are talking about 5 nodes with 4 virtual CPUs each and 8 gigs of RAM. But to get used to this technology, it's fine. And remember that you can always ask for further resources to your corresponding work package within the project, or you can self-deploy your cluster in your favorite cloud. Now, the support for multi-tenancy, I mean, currently, if you log into the cluster, you will see that there are several services deployed. We're currently deploying multi-tenancy, which is the ability that you can see only your deployed services. This is under development, expected by the end of this month, beginning of next month. But for testing, as I was mentioning, this Oscar cluster and to get acquainted with the technology, it's enough. So here you have the Oscar UI. It's integrated with EGI check-in, as I was mentioning, and here you have some links to the documentation. Now, to deploy an Oscar service, this typically requires the definition of a service in this functions definition language, which is basically the list of services or the list of functions that will be deployed in this Oscar cluster. And to deploy an Oscar service or an Oscar function, we are using the synonymous terms here, we need to specify the memory, we need to specify the CPU, we need to specify the repository on which the image is located. This is typically an entry in Docker Hub, although you may use another container package repositories. And then we need to specify the shell script that will be executed inside the Docker container that will be run upon a file upload into this input storage provider. In this case, we are using Min.io as the input storage provider. And here we can also register additional output storage providers. So for example, you can say, whenever I upload a file to be processed into Minio, this will trigger the execution of a Docker container. It will execute this shell script inside a Docker container, and the output file will be automatically stored in OneData, in Dcache, or even in both of them at the same time, in Amazon S3 or whatever. So you can create like a processing and output data pipeline. So if we take a further look into this service script, and by the way, you have any questions in each topic, feel free to interrupt and we can discuss. Otherwise, we can have some questions at the end. If we take a look at this script, basically the Oscar runtime environment provides some environment variables, and these input files is the path within the Docker container of the file that triggered this request. So we are providing automated data ingestion from min.io to the Docker container runtime. And this TMP output there is another variable that indicates the path where the output files of the data processing should be stored. So in this case, for the models that are available in the AI for EOS marketplace that are using the DPass API under the hood, and this is common also for the Imagine project, there is this handy command which is called DPass predict, which basically you pass the input file and then you specify the format of the output information, and then you store these output files in the specific location. And then Oscar is in charge of taking the output files and, depending on the service definition, storing it either in min.io, in Dcache, or whatever you specify. Now, to create a service with the Oscar UI, it's quite easy. It's connecting to this URL, specifying the details, and creating the service. So let's take a look at this simple video to deploy an Oscar service for this body pose detection that is a model available in the EA for EOS dashboard. So let me just go full screen, and let me speed it up a bit for the sake of convenience. So you will see that we logged in with EGI check-in into this Oscar cluster, and we are specifying how to deploy a service, in this case using the Oscar user interface. Here we're using an example of the body pose detection pre-trained model, and then we specify the location of the Docker image in Docker Hub. You see this image already has the DPass API inside, and we specify the script that we want to execute. We select the script and we create the Oscar cluster, the Oscar service, sorry. We specify the CPU, the memory, and we have some parameters such as customizing the min.io endpoint, specifying the outputs. In this case, the output data will be stored directly in min.io, which is the object storage system, which is inside the Oscar cluster. And we specify the outputs. Here we're specifying that the output will be in a folder of the corresponding bucket in min.io. And this is a created service. So this is a input folder. So whenever we upload a file there, then this will trigger the execution of the Oscar service. And we will see that the execution finished. We see some logs there. And that's how easy it takes to create an Oscar services there. Let me move to, sorry, we move to full screen again. Okay. Okay, so the other approach is the main approach that we were discussing is this asynchronous execution. So remember that we are doing is we are uploading files to min.io. This triggers the execution of the service, and this stores the output in another min.io bucket. And remember that we can use this output min.io bucket to trigger the inference of another Oscar service, even in another cluster. So we can create AI inference pipelines across multiple Oscar clusters, and even within the same Oscar cluster. So we can chain AI inference pipelines with these object storage systems. Okay, let me just tackle the Oscar CLI. Now, this is another approach to use an Oscar cluster, which is more powerful. In the command line interface, you can manage the lifecycle of an Oscar service. You can apply an FDL file, which has the definition of the of the service. You can also invoke a service synchronously and asynchronously by uploading a file to Min.io. It is integrated with EGI check-in as well. So you just need the OIDC agent installed and just create a link with EGI check-in client. And here you have a link to the documentation. So if you want to use this using the Oscar CLI, you need to register the existing Oscar cluster in this Oscar CLI, which runs on your laptop, on your computer. And then we can use it to create, again, an Oscar service, and then to trigger the execution of the inference. So let's take a look at this, how this works using this video. So here what we have is we have the cluster for imaging, and here we have the Oscar CLI. Let me just speed this up a little bit. And we have the Oscar CLI, and we are listing the services already deployed in the cluster. You see that they are the same that we are seeing with the user interface. And now what we're doing is we are taking a look at the definition of the service, which is this YAML file, which supports the functions definition language. We are applying this YAML file, and this creates the service within the Oscar cluster automatically. So it's creating a service in the Oscar cluster. We list the services, and we see that there is a new service already deployed there for plants classification, and it has a couple of this plants bucket and an input folder and an output folder. And we are using this image as example to trigger the inference. So we are using this put file, which basically uploads a file to Min.io from the command line. You can also do this from the user interface as well, but it's more convenient from the command line for easy reproducibility. And this triggers the execution of this service, and we can see some logs about the execution. And we'll see that in the output folder, we have the image, which is the output of the inference process of this pre-trained AI model. And we'll see that these are the predictive labels of the image. And we are using here the plants species classifier model from the AI for EOS dashboard. We can get the file as well using the command line interface. So we have like multimodal approach to interact with the Oscar cluster. We can interact through the API, through the graphical user interface, or through the command line interface. Now, we already covered the asynchronous invocations, but if you want to, let's say, achieve low latency, less than a second, you can also expose scalable HTTP-based endpoints. We are using Knative under the hood to perform these synchronous executions. So basically, Knative maintains an active pool of Docker containers up and running to allow to achieve fast response time. So we are able to reduce this, let's say, latency to obtain the results to less than a second with these synchronous executions. And we can do this also from the user interface again, invoking and uploading a file and obtaining the results, which we will see in this small video. And you will see that we are logging again with EGI check-in. We select a service, an Oscar service that's already deployed, the plans classification. We have selected a file to the invoke. We upload the file. Now we're customizing this interface to show a preview of the file instead of these binary contents. This is still pending to be integrated. And now this triggers the execution. And under the hood, it's triggering the execution of a Docker container. And it obtains the results, which is basically a JSON result with some labels and some links to Wikipedia to check the most feasible, recognized plant. So this is doing the synchronous invocation from the user interface. Now, if you want to run a synchronous job with Oscar CLI, it's also very convenient. It's just doing a service run. This is the name of the service. And we pass the image, and we pass the configuration to connect to the cluster. So, I mean, we don't have a build for this, but it's very convenient. Now, There's also another approach, which is to deploy exposed services. This was a request coming from the AI for EOSC project. And the request was to be able to expose within an Oscar cluster a pre-trained AI model with the DPass API, but you expose outside of the cluster this DPass API so that the integration with other tool is done at the level of the DPass API. So Oscar is not being seen, it's only managing the underlying auto-scaling. And here what we have is we have a bunch of containers up and running with a load balancer in front of them. And we provide seamless auto-scaling based on the average CPU within certain user-defined limits. So if you receive a bunch of inference requests, we are able to spin up more Docker containers. And once this up to a level defined by the user, and once the CPU load is reduced, then the number of containers active is reduced up to the limit, the lower limit specified by the user. So it's load balanced of containers processing the inference requests. This is a quite recent development that we integrated. You will see here this min scale and max scale that defines the scalability limits of these exposed services. Now, let's take a look at this functionality to deploy exposed services. And here we'll see that we are logging with EGI check-in again. We're using the Oscar CLI. Let me go full screen. We're using the Oscar CLI to list the number of cluster register. And we see the FDL file to deploy. In this case, it's an Nginx server. And plans classification, again, example from the AI for EOSC dashboard. So we are deploying these two services, and we see them reflected in the user interface. And we will see that the container was already deployed, and we can access the Nginx user interface directly. Now we're exposing the plans classification, and we connect, and we see the DPass API. This is the DPass API directly accessible from outside of the cluster. And we can interact with the DPass API issuing curl requests, for example, or using another HTTP client. You see that this is a bit more convoluted than using the Oscar CLI or the user interface, but this allows to directly interface with the DPass API running in the Oscar cluster. So what's the benefit of this? The benefit of this is that if you have a model with the model weights already loaded in memory, then you are reducing the load of model weights, and you can achieve faster response times for, I will not claim real-time inference, but faster than, of course, an asynchronous job, which seek, by the way, more, let's say, high throughput computing, the availability to run several jobs, long-running jobs in parallel. And we are removing these services. Let's go back to the presentation. I think it has some troubles. Once you go to full screen, it doesn't allow to. Okay, there we go. Okay, some use cases to draw some inspiration. This comes from another project. This comes from the AI Sprint project, in which we were using Oscar to create AI inference pipelines along the computing continuum. Here we have the edge of the network, and we have a set of cameras in which we want to perform mask detection usage, and we are capturing videos. We're doing some anonymization of the images in this cluster of Raspberry Pis, and then the output files are uploaded into an Oscar cluster in the EGI Fidelity Cloud to trigger the mass detection usage, which is a more time-consuming process. And then the output, the annotated images, are stored in one data in EGI Data Hub. So here we have an AI inference pipeline along the computing continuum, because Oscar can run in a cluster of Raspberry Pis, and it can also run in a Fidelity Cloud such as EGI. Now I'm reaching the end of my presentation. So where are we using this technology? I mean, we are using Oscar in both for EOSCA and Imagine projects. We want here to provide multimodal scalable inference of these pre-trained AI models on dynamically provision and also manage the Oscar clusters, as I was mentioning. In the AI Sprint project, it has been supporting all the different use cases. It's a project that just finished end of December last year, and we have the final review next month. And it's supporting all the use cases regarding personalized healthcare. You have some sensors that take information on your body conditions, and these are sent into an Oscar cluster running at UPV at our institution, and this triggers some models in order to detect the possibility of atrial fibrillation. And for maintenance and inspection, what we have here is some drones. They are going through some windmills. They are taking images, and these images are being processed in Oscar clusters in order to detect defects in the blades of the windmills. And in Farming 4.0, they have a tractor, and this tractor have a box inside the tractor. This is running an Oscar cluster inside, and the tractor is taking some pictures of the vineyards, and it detects whether there are some diseases, and there are some sprays in the back of the tractor, and it dynamically detects the amount of chemicals that needs to be sprayed depending on the state of the leaves, as evaluated by a pre-trained AI model running in an Oscar cluster. We are also using this technology in InterTwin. Here we're supporting event-driven data processing from DCAT, and we have a very nice collaboration with INFN to integrate Oscar with HPC clusters in order to provide a gateway from the cloud world into the HPC world to support event-driven computing in these kind of infrastructures. Now, some documentation and support, and I want to convey the message that you actually don't need to really get used to this technology. If you provide us with the repository of your Docker image, a sample input file used for inference, and the command line that you require to run is, in the container to trigger the inference, we can create the Oscar service for you and provide, let's say, a one-on-one support. The other approach is that you try, if you have any troubles, you can contact us using several means. And I want to convey the message that the UPB team is here to help you. I mean, this is not technology that we leave you and you will bang your head against this. We have a couple of engineers that can get you kick-started with this onboarding of models within an Oscar cluster. And you are also provided a sandbox in order to let's say, do your test if you feel you want to do so. Now, more information about this. We have this docs.oscar.dockericap.net. You have a comprehensive documentation. We also maintain an active blog in which we include some use cases coming from other projects. And you have the Oscar playlist in our research group's YouTube channel to gain further information. And as promised, this was like a 40-minute overview, and